Hey, ladies and gentlemen, welcome to 7-4. This is the land of Burmanation. We're talking about scientific notation. Not a whole lot of brand new things with this stuff, but some ideas that we've been using for the last couple of lessons that we're going to need to kind of repeat and rinse in this one. Or is it rinse and repeat? I keep saying that one the wrong way. All right, so big ideas. If you recall from years past, scientific notation. If you're going to move it from standard form to the scientific notation form, you're going to move the decimal point to the right of the first non-zero digit, which means if I had this for my numbers, I needed the decimal to be right here in between the first two numbers to be in scientific notation. Your job is to note how many times the number moved or how many times the decimal place moves. So in this case, it's 1, 2, 3. So that would give me my F times, this is my F, 1.094 times 10. The 3 times tells me what my exponent is. And if you move to the left, it is positive. If you move to the right, it would be a negative exponent. So those are ideas that we should have from years past, but we're going to practice them really quickly here. So in this first problem, writing into scientific notation, the decimal point starts here and it moves and it needs to end up in between the 4 and the 0. So I'm going to have a 4.062 and I'm going to write down all of the numbers until the repeating zeros start to happen. And the whole point of scientific notation is to write these really, really big numbers in a much faster way. So here's a really, really big number. So I'm going to count now how many spots that we moved it to. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 12 would then be my exponent. Now, it might be easiest to draw these little whoop-de-whoops or waves or whatever you want to do to count the number of spaces to make sure that you count the correct number. And because this number is really, really big, we're going to have a positive exponent. Now the next one actually has a really, really small number. Now my decimal point is going to go in between the 8 and the 2, and I'm going to write down the 3 as well because I have all the repeating zeros are over here on the left hand side. So my job is just to count how many times I move the decimal point. 1, 2, 3, 4, 5, 6, 7 times. So we moved it 7 times. It's always times 10 because we're talking about our number system. And our number system is a base 10 system because there's 10 spots in each place value. And what number did we say? 1, 2, 3, 4, 5, 6, 7. So that's my negative 7 because I moved to the right. And it's a really, really small number. So I made this really, really small number into scientific notation. That's why it's a negative exponent. All right, another big idea here. I think you can't see all of it because I got a fat head in the way, so I'm going to move it down. There we go. Boom. And it says that we're supposed to review how to change scientific notation into standard form. It's the exact opposite of what we just did. So if we have a positive exponent, we're going to move the decimal to the right however many places. And if it's a negative exponent, we move it to the left. So in our examples here, example A, I'm going to have my 649, and because I have a positive exponent, I'm going to take that decimal and I'm going to move it 1, 2, 3, 4, 5 times to the right and make my new decimal spot. All these open waves get filled in with zeros, so my new number would be 649,000. So that's how we do those problems. So that's A. Part B for this example, part B is for us to take that 1.8 and move it 3 times to the left because it's a negative exponent. So the exponent tells us how many times we're going to move things. We're going to go 1, 2, 3. I'll put a big dot there and I fill in, again, the open spots with zeros. So my official decimal now is 0.0018. And that would be my answer. Up here, the answer was, I should do it right again, was the 649. All right, so as you can imagine, these are things that you learned probably in previous years. Here's how I make it harder. We take and we multiply scientific notation numbers together. So I'm going to multiply the like terms It's not probably the correct terminology, but it's the same idea. The like terms together. So I'm going to multiply my numbers that are in the front together. So my 5 times my 2.3. And then I'm going to multiply together my powers. So 5 times 2.3 gets me to the answer of 11.5. So I did 5 times 2.3 in my calculator. And then I'm going to multiply together my 10 to the 6th times my 10 to the negative 6th times 10 to the 12th. So we're going to use our rules from 7-1. If we multiply with the same base, we add the exponent. So it's going to be times 10 to the positive 6, because a negative 6 plus 12 makes a 6. Now here's our problem, is we do not have this in scientific notation, so it needs to get there. So we're going to move 1 time to the left, which makes this number smaller. So we're going to be at a 1.15. What we're going to do then is we're going to add to our exponent, because we moved this number to make it smaller, which means this number has to get bigger. So it's going to be times 10 to the 7th to make up for that whole move, because we have to multiply by one more 10 to make this all the way to the correct number. So this is your correct answer of 1.15 times 10 to the 7th. Now we're going to use that same idea for this one. This will be the one that I ask you guys to do on your own, and then we'll start class with talking about this specific problem. Same idea as you're going to simplify the things that go together and simplify the things that go together. See if you can put that into scientific notation and into standard form, folks. All right. This is the Burma Nation. Hope you guys have a wonderful day.